Hi everyone. So we are continuing our lesson 1.4 on solving inequalities. We have already talked about how to read an inequality. And we always read starting with the variable. So sometimes we have to switch the variable and the number, which also means we have to flip the inequality symbol. Now, how are we going to solve them? So open your notes to the inside. And you'll notice these look just like equations, except we have an inequality symbol. Now that does change things a little bit. So let's look over here in the upper left-hand side. And I put some directions there. They're not on your notes. I added them myself. We're going to take this simple inequality statement that you see, and we're going to multiply by 2 and divide by 2. We're going to multiply by -2 and divide by -2. So looking at that inequality statement, 2 is greater than 1. Think about whether that's a true statement or not. 2 is greater than 1. Yes, so it's true. Okay. But what were to happen if we were to actually multiply both sides by 2? Would the statement still be true? So I'm going to multiply this side by 2 and multiply this side by 2. So 2 times 2 is 4. 1 times 2 is 2. And let's read that last statement that I just wrote. Hold on, it's taking a moment because it's lagging. It is true. 4 is greater than 2, so that's a true statement. So it is okay to multiply by 2 on both sides. What about multiplying by -2? Let's see what happens. Multiply by -2. Okay. So -2 times 2 is -4. And then 1 times -2 is -2. Now let's read that statement. Is -4 greater than -2? No. So that came out false. Okay, so take a moment to do the last two. Pause the video and do the other two. All right, so hopefully you've looked at the division. When we divided by 2, we got that 1 is greater than 0.5. Because 1 is greater than 0.5, that's true. But what happens when we multiply by -2? Or divide by -2. So 2 divided by -2 is -1. 1 divided by -2 is -0.5, or you could write it as -1/2. Now, -1 is not greater than -0.5. It's more negative, so it is definitely smaller. So it is false. So notice that our statements that are false are when we multiply by a -2 and divide by a -2. So it does have something to do with it being negative. So how would we make those statements true? We would take those symbols and flip them, right? Because right now it's saying that -4 is greater than -2. If I were to flip that, it would say less than and make it a true statement. So when we are solving, and this is very important, this special case right here, I would definitely highlight it if you have some highlighters nearby, that when we multiply or divide by a negative number, we have to flip the symbol to make it true. So keep that in mind. This is a very important rule that a lot of people forget when they are solving. Okay, so super important. Make sure that you've highlighted it, starred it, so that you can come back to it, because you'll need it right now when we're solving. So we're going to do a few examples of how to solve a basic one and then a harder one, and then I'm going to have you try the rest and I'll reveal the answers. So let's look at number 1. Okay. So we're going to go ahead and solve. Okay. I'm going to start off, remember we're solving just like normal, so I'm going to draw a line where my less than or equal to symbol is. To get f alone, I need to get rid of the +5, so I'm -5 on both sides. 5 minus 5 is 0. 7 minus 5 is 2. So we have our answer because f is alone. So f is less than or equal to, so we're going to write that over here. Our answer is all values less than or equal to 2. When we graph on a number line, there's a few things that you do need to know. If you see a symbol with a bar underneath it, less than or equal to or greater than or equal to, it's going to be a solid dot on your graph at that point. But if it doesn't, if it's just less than or greater than, it's going to be an open dot because those points are not included. It's just less than that number. It's not equal to it, so it doesn't get a solid dot. So I'm going to go ahead and put a few numbers on my number line. I'm not going to put every number. Okay. So we can see -2, -1, 0, 1, and 2. Since this is a less than or equal to symbol, I'm going to put a closed dot at 2. And now I need to decide what direction am I going to draw my arrow. Keep in mind it does say less than, so less than would mean go left. Okay, so that means all of the numbers to the left of 2 are all solutions. And also you'll notice that the less than symbol looks like an arrow pointing to the left. So that might also help with graphing. So let's look at one that might be a little bit harder. Okay. What about if we had variables on both sides? So I'm going to do one that's on the right side of your notes, number 5. Okay. So I always try and get my x on the left by itself and eliminate the one on the right. And my reason for doing that is because then my answer always has x on the left. I always want my x on the left. So it helps with reading the answer and knowing what it means. So I always get rid of the one on the right, which in this case is -2x. And so to get rid of a -2, I need to add 2. So I'm adding 2x to both sides. I get -3x, -5 plus 2 is -3. Bring down the 8, bring down the less than or equal to sign, and bring down that 23 as well. Let's continue to solve. Remember what the goal is, to get this x alone. So to get rid of a +8, we -8 to both sides. 8 minus 8 is 0. So we've got -3x is less than or equal to 15, 23 minus 8. Now here's the important part. Remember that rule we talked about, okay? There was a rule on the left side of your notes that says if we multiply or divide by a negative, we have to flip the symbol. So remember, multiplying and dividing is always our last step. So when you get to your last step, you need to remember this rule. Am I dividing both sides by a negative? In this case, to get that x alone, I have to divide by the number in front of the x, which is -3. I did just divide by a negative number, right? Which means that my symbol here is going to have to flip. -3 divided by -3 is 1, so 1x. My symbol flips. It is no longer less than or equal to. It is now greater than or equal to. And I'm going to divide them to get -5. So this is my solution. X is greater than or equal to -5. Take a moment to graph it and write the verbal description on the right. Pause the video and then check your answer. Okay guys, check to see how you did on this graphing. Remember, look at the symbol we ended up with. It was x is greater than or equal to -5. So if you forget which direction it goes, remember you can take the symbol and make it into like a little arrow, and it kind of tells you the direction you should shade. So I'm shading to the right, and because it is has a line underneath it, it's equal to, and that means it is a solid dot. Okay, so all of those numbers are solutions: -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, all the way to a million, infinity, every number bigger than -5. The only numbers that aren't solutions are the numbers below -5 or less than -5. So what I'm going to ask you to do is practice these questions, specifically the ones on the right. The ones on the left are important, but the ones on the right are multi-step, and I want to make sure you know how to do those. So at least try 6, 7, and 8. Please notice there is a typo. You may want to change that letter M to an X in number 8. So please give questions 6, 7, and 8 a try. Pause the video, and then unpause to check your answers. Okay, let's check our answers. Here's number 6. Please note that even though our answer was negative, the symbol did not flip. It's only when you divided by a negative number, and we divided both sides by +4. So that symbol still stayed less than or equal to -6. Here's number 7. please check it. Notice that I always got rid of the variable on the right side. I always got rid of the variable on the right side so that my remaining variable would be on the left always. It makes it easier to read, and on the STAR test, the variable is always on the left, so that does make it easier. Remember, if you need to pause while I'm going through these, make sure to pause, look at it, and then unpause the video again. And number 8 was a little bit longer because you did have to distribute, and you'll notice you did get a decimal answer as well. When you distribute, don't forget that a -3 times a -1 is a +3. And I also had to combine like terms in this one. 9 and 3 got added to give me 12. Okay, and also notice I did divide both sides by -5, so my symbol flipped at the end. And because it's a less than, not less than or equal to, we have an open dot. Okay. I'll also show you the examples that are on the left so that you can see if you got those right also. Remember, pause the video if you need to. Here are the answers to 2, 3, and 4 for those of you that needed to see them. If you have questions about any of these problems, please raise your hand and your teacher will come help you and explain the errors. Here's what your notes should end up looking like. Thanks guys for being so awesome and doing a video lesson today. You're amazing. Remember that. For Miss Yanasek students, remember I have tutoring every morning except Wednesdays at 8 a.m. So I hope to see you there. Have a great day, guys. Bye.